In this video, we will understand different parts of data engineering in just 10 minutes. Take the example of any company such as Google, Amazon, Netflix or Uber. All of these companies collect data to understand their user behavior so that they can provide better services and improve their product. So there are different problems available, and using data they can easily find the solution to all of those problems. So first of all, we have a business. Without business, we don't have data engineering, data science or machine learning. Business can be anything till it is generating data and we can extract the value out of it. Amazon generates data every time user visits their website or orders something. When you book a cab on Uber or when you like something on Instagram, data is generated. Everything you do online, the data is generated and stored. But the question is, where do we even store all of this data? To store data, we have something called as database management system. It is basically an organized way of storing data in computers. So there are mainly two types of it. One is relational database that basically stores data in row and column format. And on the other hand, we have NoSQL database. It stores data in different formats such as key value, document, graph, etc. Now, depending on the requirement, companies store data. Facebook wants to define relationship between different users, so they use graph-based database. While in the case of Amazon, they want to store information about different orders, so they use relational database. Every type of database has its own application and requirement. Let's focus on the first type of database that we talked about, that is relational database. This is where most of the companies stores their data. To build a relational database, we need to build something called as data model. It looks something like this. We can easily understand the relationship between different tables, and it is much easier to understand the entire picture. So now we just stored the data, but we also want to understand what is happening inside our data. So we have a scripting language called as SQL, structured query language. Just like we use different language to communicate such as English or Hindi, SQL is the same for database. We can use SQL or structured query language to communicate with the database and get the right data in the output. You just have to pass some basic commands and database will give you the final output. Such as if I want to select the first 10 rows from the table, all I have to write select star from the table, name, limit 10. This will return 10 rows. You can also perform a lot of different operations such as insert, update, delete and many more. Here are the highly used keywords that I use as a data engineer in my daily life. With query language, we also have the programming language that provides more flexibility on database. So you can use programming language, connect to the database and perform more operation on top of data. You can use Python, Java or any of the programming language till it supports a basic database connection and functions to perform all of those operations. So you can query the database, fetch records and apply different logic on top of it. As a data engineer, you have three choices: Python, Java and Scala. You can pick any of the programming language. I have a detailed video on this topic, so I will put the link in the description. You can go and check it. So everything we talked about till now is not a data engineering. This is how normal system work. We have some application, user is interacting with that application. We get some data, we store that data onto database, we fetch the data and display it on the website or application. So this is how the normal system works. Data engineering starts once we have our data in database, and what we do after that. As we discussed in the start, that every data project has one goal in the end, is to solve business problem. This can be done using building dashboard, metrics, machine learning models and many more. The journey of having data in database to building a dashboard or machine learning model to solve business problem, this is where data engineering happens. There are many different steps involved in this process, and every company has its own way of doing things, so they use right tools based on their requirements. So now we will try to understand the data engineering process. Are you ready? Let's get started. The first question you should have in your mind is that why do we even need all of these processes on the first place? Why can't we run the SQL queries on relational database and get the value out of it? The problem is relational databases are not designed for analysis work. I tried to do this in my first job. I ran the large analytics query on the PostgreSQL database and it took the entire database down because these databases are not designed for this type of work. The relational databases are designed for faster reading, write and update. But to analyze the last 5 years of data and gain insights from it, we need something else. So there are basically two types of processing system: OLTP, online transactional processing, which we are currently using to store our data, and second we have OLAP, online analytical processing, that we use for analysis so that we can gain insights from the data. OLAP system are specially designed for analytics work. So if you want to understand last 5 years of revenue, you can easily do that in few seconds. So what we really want to do is take the data from OLTP system and put that data onto OLAP system. For example, OLTP system are Postgres or MySQL database, and on the target OLAP systems are Snowflake or BigQuery. And to do this operation, we have to write ETL pipeline. extract, transform, load. Now there are many different terms coming in the market such as extract load or extract load transform, but we will understand about this term when we talk about the modern data stack. But for now we will stick to ETL. Extract, transform, load. It basically means extracting data from one or multiple sources, transforming that data based on some business logic or based on the data warehouse design, and then loading that data onto some target location. It can be any storage or data warehouse. It is very simple. Take data from one place and put that data onto some target location. But here's the thing, business people have a lot of different requirements. Sometimes they want to see that data in real time, and sometimes they just want to see that data once a day. And for that we need to choose the right processing system. So in general we have two processing techniques. One is batch processing and second is real-time processing. Batch processing means you process the data in different batches. So last 30 days of data once a day or 4 times a day depending on the business requirement. In the case of real-time streaming, you process the data as the data comes into events. So when you order something from the Amazon, you directly receive the notification that Amazon received your order. When it is shipped, you get the notification that your order has been shipped. All of these things are happening in real time. Now to process the small amount of data, we can easily do that on our local system. But to process the large data, we need multiple computers working together that will take the data, divide that data and process it individually in chunks and then combine the final output. And to do this, we have different frameworks available such as Hadoop or Spark. You can use these frameworks to process data in batches, and if you want to process data in real-time streaming, then we have some other frameworks or tools available such as Apache Kafka, AWS Kinesis, GCP Dataflow and many more. So depending on the requirement, batch or real-time, you can choose the services or the framework and build your solution out of it. And in the market there are so many different tools available for each and every type of problem. This is what the big data landscape looks like. There are so many tools available for different type of work. You have to zoom in just to read the tool's name. Now all of this processing requires the large system. We are processing the terabytes and petabytes of data. We can't do that on our local PC. For that we need supercomputers that looks like this. Now historically all of these companies used to build these servers by themselves. They used to go buy RAM, disk, power supply and all of the other things and configure it in their local data center. But this also comes with a lot of maintenance, upgrading software, making sure power supply is running, hardware failure and many more. So these days companies are directly moving to cloud platform because you only pay for the resources you use. New startup companies are directly going on cloud platforms, and some of the old companies are moving from on-premise to cloud networks or the hybrid network. So there are many different advantages of moving to cloud. You only pay for the resources you use. You can easily scale up and scale out your servers. You can manage large volume of data, and cloud providers also provide a lot of different services that will make your life much more easier. So as per this Gartner quadrant that ranks different cloud platforms, these are the top 3 cloud providers available in the market: AWS, Amazon Web Services, GCP, Google Cloud Platform and Microsoft Azure. I started my career with AWS, but you can start your career with any of the cloud platforms because once you learn one cloud, you can easily learn any other cloud. All of the fundamental services of cloud platforms such as VPC, EC2, IAM, all of those are similar. So once we have our entire architecture running on cloud platform, everything is running fine. ETL pipelines, we have the data warehouses that we can run analytics on top of it. Then we can have data scientists or machine learning engineers who can use this data to build machine learning models, deploy it in the production so that we can improve the business and gain more insights from it. Now here's the thing, as one industry grows, in the case of data engineering, we also find a lot of different problems available in the market. Let's take the example of migrating data from on-premise to cloud network. A lot of different companies are trying to do this, and in this process they find many problems and they try to build a solution from it. If one person is facing this problem, there might be chances that 1,000 people are also facing this same problem. This is where the companies find the market gap and new tools comes into the market. So companies find the problem and build the solution or the new tool out of it. This is what we call as the modern data stack, because companies are trying various things, and while doing this they also find a lot of problems and build a solution out of it, and they try to sell this solution to all of the different companies who might be facing the same problem. So we have the traditional way of doing things such as writing ETL pipeline, but the new processes or approaches are being developed, and based on that the new tools comes into the market. So this is where we do things in modern way. So instead of writing the manual ETL pipeline, we can directly use tools such as Fivetran. Why do you even write ETL on the first place? Instead, just load your data into your data warehouse and then transform it based on your requirement. This is where the tools such as data build tool comes into the picture. Just like this, there are many different tools coming in the market, and here's the list of it. You can go and explore them. Now don't get attached to any tools. Tools will come and go in the market every 6 months, but the fundamental concept will still be the same. Understanding programming language, SQL, understanding the data processing system such as OLTP and OLAP, all of these fundamental concepts will remain the same. So have the strong fundamentals, but also learn the new tools that are coming into the market so that you can stay relevant in this space. I hope you found this video insightful, and if you did, then make sure you hit the like button. That will help my channel to grow and reach more and more people. And don't forget to hit the subscribe button. Thank you for watching. See you in the next video.